George Starkey was a groundbreaking colonial American alchemist, medical practitioner, and writer whose work resonated deeply throughout Western Europe. In this video script, we examine his life, scientific methods, and technical achievements with a friendly, conversational tone that still respects the complex details of his work. We begin our journey by looking into his formative years, his Harvard education, and the early development of his experimental techniques. Along the way, we explore his transformation into Eirenaeus Philalethes, a pseudonym that allowed him to share his revolutionary ideas while maintaining secrecy. Not only did he develop innovative alchemical apparatus, but he also crafted sophisticated pharmaceutical remedies, often incorporating precise mixtures and complex experimental setups. His work attracted attention from peers such as Robert Boyle, among others, who benefited from his technical insights and methodological innovations. We also discuss his challenges, from economic pressures to bouts of incarceration, all of which influenced his scientific legacy. This script provides a detailed, numbers-driven analysis of his experiments, including furnace designs, compositional data for mercuries, and procedural methodologies that laid early foundations for modern chemistry. By drawing on both extant laboratory journals and historical records, we reveal how Starkey's experimental approach advanced the understanding of chemical forces and particle interactions. George Starkey was born in Bermuda as the eldest child of George Stirk, a dedicated Scottish minister, and Elizabeth Painter. His early life was steeped in a rich cultural and religious environment, where Calvinist ideals and the values of natural history were deeply imbued. Even as a child, Starkey showed an insatiable curiosity about the natural world, meticulously recording observations of local insects and plant life that revealed his early predilections for empirical inquiry. After the passing of his father in 1637, his educational path redirected him to New England, where he further honed his intellectual abilities. In New England, young Starkey absorbed both classical teachings and the nascent ideas of alchemical theory. His rigorous environment was notable for blending traditional scholastic subjects with emerging experimental disciplines. While residing in New England, Starkey began developing the foundational skills that would later influence his medical and alchemical practices. At the tender age of 15, Starkey matriculated at Harvard College, embarking on an academic journey that introduced him to a broad curriculum. Immersed in classical languages, theology, logic, mathematics, politics, and history, he received a well-rounded educational foundation. However, it was the introduction to natural philosophy and alchemical theory that truly captivated his interest. Through rigorous coursework in physics, he became familiar with the principles of metallic transmutation and the subtle interactions of particle theory. These subjects not only enriched his theoretical understanding, but also spurred practical experimentation with chemical substances. Starkey's studies at Harvard instilled in him a fascination for the underlying forces of nature, pushing him to question traditional boundaries and embrace innovative scientific methodologies. The academic environment at Harvard was both challenging and inspiring. Its curriculum laid the groundwork for what would eventually evolve into his technique known as chemistry, a precursor to modern chemistry. At the age of 22, Starkey left New England for London, driven by a desire for superior laboratory resources and better quality materials essential for his alchemical experiments. Arriving in November 1650 with his wife, Susanna Stoughton, he quickly integrated into the burgeoning scientific circles of the city. In England, he not only established himself as a competent physician, but also became renowned for his innovative approaches to chemistry. Starkey's relocation provided access to refined furnace apparatuses and high-grade metals, which were scarce in the New England colonies, enabling him to pursue metallic transmutation experiments with enhanced precision. It was during this period that Starkey adopted the pseudonym Eirenaeus Philalethes, a name laden with significance. The choice of pseudonym, meaning lover of truth, reflected both his personal philosophy and the practices of the Hartlib Circle, a network of radical reformers and natural philosophers. Enigmatic by nature, his alternate identity allowed him to disseminate his discoveries while safeguarding the trade secrets of his sophisticated chemical processes. This rebranding coincided with an increase in his experimental output as he published treatises that were rich in technical detail and numerical analysis, appealing to the learned audiences of both England and continental Europe. Moreover, Starkey's adoption of a new surname, changing from Stirk to Starkey, remains shrouded in mystery, suggesting a deliberate attempt to redefine his professional persona. Upon arriving in London, Starkey rapidly built a dual career as both a physician and an alchemist. His medical practice was marked by the application of iatrochemical methods, drawing heavily on the teachings of Flemish iatrochemist Jan Baptist van Helmont. This approach emphasized the chemical analysis of bodily fluids and the preparation of mineral-based remedies. Starkey's diagnostic techniques often incorporated quantitative observations and precise measurements, reflecting his deep commitment to experimental rigor. Concurrently, he embarked on ambitious alchemical investigations, focusing on the transmutation of base metals into noble ones by employing sophisticated furnace designs and carefully calibrated heat treatments. Starkey's laboratory became a site of constant innovation, where he experimented with various formulations and mixtures. One notable invention was his sophic mercury, a compound purportedly capable of dissolving gold while acting as a catalyst for further transmutation. This intricate process demanded exact ratios of antimony, silver, and mercury, along with precise thermal conditions, and was documented extensively in his laboratory journals. These journals are today prized for offering quantitative insights and procedural detail that help modern researchers understand 17th-century experimental protocols. Starkey's engagement with the technical challenges of alchemy not only advanced chemical apparatus design, but also contributed to early concepts of corpuscular theory and particle interactions. During this period, Starkey's work garnered attention from several prominent scientists, including Robert Boyle, who was influenced by his methodical approach. Despite his professional successes, Starkey faced significant challenges. Ambitious projects in perfume manufacturing, pharmaceutical production, and experimental chemistry strained his finances. To fund his many ventures, he often resorted to self-financing advanced experiments that, while innovative, were expensive and resource-intensive. These combined pursuits ultimately led to mounting debts and a temporary dissociation from his earlier patronage networks. Nevertheless, his relentless drive to combine medical practice with chemistry spearheaded a transformative era in both fields, setting technical precedents that would guide future experimental methodologies. Starkey's career in London thus stands as a testament to the complex interplay between scientific innovation and economic sustainability in early modern research. In addition to his laboratory triumphs, Starkey maintained extensive correspondence with fellow researchers, exchanging detailed accounts of experimental procedures, quantitative findings, and innovative apparatus configurations. His letters reveal meticulous calibration of instruments, the careful adjustment of furnace temperatures, and rigorous measurement of reaction yields. This documentation not only advanced his own work, but also provided vital benchmarks that informed subsequent scientific experiments. Starkey's experimental endeavors were characterized by a combination of precise quantitative methodologies and innovative device construction, leaving behind a legacy of technical rigor. One of his most significant experiments involved the production of sophic mercury, a corrosive amalgam intended as an intermediary in transmuting base metals into noble ones. This process required him to carefully combine measured amounts of antimony, silver, and mercury, subjecting the mixture to controlled heating cycles with exact temperature gradients. His laboratory notebooks detail the numerical ratios used, the duration of heat treatments, and the resulting chemical changes observable through early forms of spectroscopic analysis. Beyond the production of sophic mercury, Starkey conducted experiments with various solvents and alkahests in his search for the elusive philosopher's stone. Detailed records reveal that he experimented with over a dozen different solvent formulas, meticulously adjusting reagent concentrations and documenting their yield efficiencies. His writings include comparative tables that list reaction times, the quality of transmutations, and even rudimentary calorimetric measurements. Such detailed accounts provided a critical bridge between alchemical tradition and emerging modern chemical analysis, emphasizing the role of insensible particles and inherent chemical forces. Moreover, by mentoring figures like Robert Boyle, Starkey indirectly influenced the course of modern chemistry. Despite his significant contributions, Starkey's career was marred by persistent financial difficulties. His ambitious projects required substantial investment, and his self-financed experiments often exceeded available resources. As the costs of high-quality materials and advanced laboratory apparatus escalated, Starkey found himself increasingly indebted. Financial pressures grew as he pursued simultaneous ventures in alchemy, medicine, and pharmaceutical production. Eventually, these mounting debts resulted in his incarceration. Starkey was imprisoned for debt not just once, but on at least 2 known occasions. While his time in confinement was brief, it disrupted his research and strained his professional network. His inability to reconcile the conflicting demands of scientific ambition and financial stability became a cautionary tale among his contemporaries. Even as he worked diligently to re-establish his practice, the specter of debt lingered, undermining his efforts to secure further patronage. As the Great Plague swept through London in 1665, Starkey's life met a tragic end. Despite his steadfast adherence to Helmontian medicinal principles, his specially prepared alkahest failed to prevent infection. In his final days, he continued to experiment on a modest scale, determined to refine his methods until the very end. The inevitability of the plague underscored the limits of contemporary medical and alchemical practices. George Starkey's work left an indelible mark on the development of early modern science. His rigorous experimental methods and detailed laboratory records provided a framework that influenced luminaries such as Robert Boyle, John Locke, Gottfried Wilhelm Leibniz, and Isaac Newton. By integrating quantitative analysis with innovative alchemical techniques, Starkey helped shift scientific inquiry from mystical interpretations to experimental approaches based on empirical data. In addition to his historical significance, Starkey's work resonates with contemporary scientific inquiry. Modern researchers have revisited his manuscripts to uncover early applications of quantitative measurements and chemical analysis techniques. His detailed experimental records have provided a model for statistical evaluation of reaction outcomes, influencing current methods in analytical chemistry. The Hartlib Circle, with which he was associated, exemplified the collaborative spirit of early science, a tradition that finds echoes in today's interdisciplinary research collaborations and open-source scientific communities.